Okay, welcome back to PALS TV, everyone. Next, we will be going live to Columbus, Ohio. Actually, we're going to be in another location today, though, down at Art Outside the Lines instead of our Columbus program, to do some weird science with Professor Phil. Science is crucial to understanding what's happening with us right now, and Phil does a great job relating it to the virus and what's currently happening in our society. So we want to keep everyone safe. That's most important. Science helps us learn and understand that. And Phil gives us a unique spin to really help us grasp what's going on in our society. So it's been nothing but great segments in Columbus, Ohio. I'm sure today will be no different. So live from Art Outside the Lines, Professor Phil with his assistants, Bianca and Audrey.
All right, as Aaron said, we're down here at AOTL in their parking lot where we've got good concrete underneath us and everything's plain. We have assistants this time because I don't want to destroy the camera. So Bianca is working as our camera person and Audrey is our fire safety officer. What we are going to do today is not as safe as what we did last time. Today is all about different types of fire and what we can do with that and how that helps us understand the world. So again, safety is our first thing, so we need to get rid of the coat and put on the lab coat. Because if I catch the coat on fire, I want to be able to take it off. You will have noticed that not only I, in a second, but Bianca and Audrey are both wearing goggles, particularly when you're working with fire and there's a chance of an explosion. You don't want to lose an eye, so be careful of that. Anytime you're doing anything physical, your basic check word is watches, rings, and dangly things. Make sure you don't have any of those on. I do have my pocket watch, so I will take that out just in case it slips out of the lab coat. There we go, and put that up. And I will put my goggles on as well. Thanks for the close-up. You will also notice, I believe when we looked at the concrete, that I'm wearing my big stompy boots, and my pants and the rest of my suit is wool, which helps with stopping fires. A much easier way to do it. All right, so we're all good for safety. All right, let's go ahead and get started. The first demonstration, Sarah went. When we set certain things on fire, well, let's back up. Let's talk about how we make fire. Fire needs a fuel source. That could be gasoline or something like that, or wood. It needs oxygen, and it'll get plenty from the air around us. It needs heat, and it needs what we call an uncontrollable combustive chain reaction, or spark. That's kind of a new one. It used to just be the first three. But we know we need a spark too, otherwise it just smolders. So a lot of our fuels don't burn themselves. It's the fumes that come off of them, like rubbing alcohol and gasoline. It's just the fume that burns. You can put a match out in a bucket of gasoline. Don't try it because you will probably catch the fumes first and blow yourself up. So don't do that. So we've soaked this dollar bill in a solution of 50% water and 50% alcohol, just regular rubbing alcohol, and we're going to set it on fire.
Well, I should back up.
I cannot see that. I can feel the heat, but I can't see it in this. But you will notice, one of the problems with alcohol is that it burns a really light blue, so you can't see it. I'm going to put this out quickly. in our water. You will notice that, even though you couldn't see the flame, I could feel the heat. So it was on fire, but it wasn't burning up. That's because the alcohol fumes go to the outside. That's what we're lighting. The water that's in that solution stays in the cloth of the dollar bill. All right, now we're going to switch to hopefully a better demonstration of that. We got a normal bottle, nothing in it. And we'll pour just a tiny bit of alcohol in here. Maybe a little more. We will cap it and shake and swish it around so the alcohol covers all the inside. Now, obviously, we can't touch the alcohol. It's way down there at the bottom. But all these fumes are covering the inside of the bottle. And they will come out the top. Were you able to see that at all?
No.
I heard a big whoosh as it took off.
I know, I think the wind maybe.
And it's really hot. Yeah, I can hear the whoosh every time, but it's too bright and too light. So maybe we need another color of fire instead of this light blue.
Professor Phil's on it.
Oh, that's the wrong one. In this bottle, we have just a tiny bit of magnesium sulfate. It is a metal and a salt. Most things are metal in the world. Salts change the color of fire in different ways. One of the ways, and metals as well. One of the ways you can tell what kind of material you have is just to burn it. And by determining what color it is, you can find out what it is. So magnesium burns quite brightly. It's the same stuff we use in road flares. Other side. Again, there's nothing we're touching except the fumes here.
Whoa, I heard something.
Yeah.
Whoa! I'm scared.
We burned off all the fumes in that big whoosh. And that is really hot. Again, probably too much alcohol and not enough salt in here. Let's try it again with something else. We're going to use citric acid this time.
All right.
This one. So magnesium should have burned quite red. And it ended up being a very light purple color because of the blue alcohol. Did you hear that? That was an awesome jet of flame that, again, we couldn't see. Well, I couldn't see. I've got these shade things on because it's really bright out here. That is really warm. Nobody will believe it. Touch that bottle.
Okay.
Warm.
Yes, it's warm.
See? These are not great visuals. So, since that wasn't so good, instead of just trying to send fire up into the air, why don't we create a jet? And if you're going to do a jet, you must first go over here. The first step in setting off a jet is that right there. One must kick the tires before one lights the fire.
Don't worry, we're not setting a PALS bus on fire, you guys.
I have a mason jar, and this is almost pure methanol in here, which is a different type of alcohol than your rubbing alcohol. Again, I'm going to shake it so we get as many fumes as possible. There is a tiny little hole in the cap where these fumes can come out. I may have set this up too early. That's not wonderful. Let me switch, get some new methanol. Antifreeze, that's all you need. Except not the diluted stuff. Don't get it 50-50. That should give us plenty of fumes since it's new. So as this vaporizes, we ought to get a nice jet of flame. Or we need a bigger hole. That could also be the case.
Is it okay if I'm this close?
Yeah, because nothing's happening with this stupid thing. All right, the methanol jet engine. Another failure. Just like, which one was it the other day?
The color thing?
No, yeah, the color. No, it was the hot ice. The hot ice didn't work. This didn't work either. It may be because I got a brand of antifreeze that isn't enough methanol, though that seems strange to me. They should all be pretty methanol-y. Or there just aren't enough fumes coming up.
Fail. Yeah, maybe it's because we're outside.
It could also be the wind. There we
Come on, Phil.
go. Nope, that was not working. Let's see if we give it a bigger opening.
Oh, God.
Ready.
Well, really jet in this case. No, I'm getting nothing. That is massively disappointing. But we now have several hypotheses as to why this isn't working. So if we come back, we can test this again. We can use a different type of opening, drill a slightly bigger hole. We can use a different type of methanol to make sure we get the right stuff. And we could try doing it inside. If we were doing that, we would need to be in a big open area so we didn't get overcome by any fumes or anything. Plenty of ventilation, but we want to kill off any wind that might possibly be happening.
One of our viewers just messaged saying, get a freaking match.
I mean, this is coming out. I was worried the match would be too difficult. Oh dear. Sucked all that.
Oh, no.
What? Okay.
You got this, Professor Phil.
Disappointing jet. Let's go with rockets. I made solid rocket fuel after cooking class yesterday and put it in here. We have a small fuse. The solid rocket fuel is nothing more than potassium nitrate and sucrose, which is just table sugar. The biggest reason for these sandbags and these rails that we've been doing everything in is for this. So that we can make sure it goes where we want. As much as possible. I'm going to make sure the fuse goes
Phil, we got a message saying that you're doing really great.
Yeah, but the fire isn't. Okay, now I can see that fire.
What?
Did it travel up? I can't see it anymore.
I don't think so.
That's the problem with burning alcohol.
You can't see it?
No, that is not it. Okay, let's set that aside and let that dry a bit, and we'll try without. Because we've got 2 of these, just to make sure. Replication is the heart of research.
Mm-hmm. I don't think any fun. Oh. Oh gosh. Oh gosh.
Whoa.
Oh, it's
That is the most disappointing views on the planet.
So cool.
It was so close. What's next, Professor Phil?
Oh, we reattempt.
We're reattempting, everyone.
I'm going to put an accelerant.
Ooh, waste the hand sanitizer.
On this, tip it back over.
Woo! Yeah, Professor Phil!
Oh no, that's pretty satisfying.
Woo!
Normally we'd expect a rocket to go somewhere. This one clearly didn't. One of the reasons for that is it's just flat. Now, to go someplace, we need to push on something. So all we're really pushing on is air. So if we've got something flat and we're pushing against that same air that we're pushing with, then we're not going to go much of anywhere. That's why rockets and Formula One race cars, at least, have those sharp nose cones so they can go through the air and split through it and have less pushing against them. If I had molded these into something more cone-shaped, it would move. I specifically did not do that because I was worried that we might send this a little too far. And I don't want to burn down the art studio.
Thanks, Phil.
All right, let's get in close. All right. I can see it starting. This does not smell as nice as it does when it's cooking. It smells like candy when you cook it. You hear the delight.
Whoa.
So sweet.
Now that I'm looking at all these different things that are working and not working, and we can see and we can not see, we're learning some things. So none of it's a failure. It's just a negative result. Negative results are good results. They're publisher results. One of the things that I would do in future is switch so I can throw fire out of my hands. I skipped that because I thought it would be a little ridiculous. We're just going to put those out. And then I can scrape up the plastic later.
Phil, we just got a message saying that was so cool.
It was pretty cool. So when we couldn't get the fuses to light, we went with an accelerant, just basic hand sanitizer, which is mostly alcohol. You can, I'm told, get this to make rain. I don't know if we'll be able to see it because it was difficult to see the fire before. I'm real unsure. if the rain part will happen. I think it'll just glob out, but I'm told this works. We've just got a spoon, put a little sanitizer in it, and we're taking a fork on top. The fork is just to break the sanitizer apart so we get puddles. Get my hand as well back as possible. Get that well lit. Yeah, without setting just the fork.
Is it raining? Do you guys see that? Whoa!
Yeah, we're getting some drips of fire. It isn't great.
And we're gonna put the fire out.
Yes, we are. So, the big things we learned today is first, always safety, especially with fire. You want somebody nearby to give you a hand. Kill me. Don't laugh at me. You want somebody nearby. You want good fire equipment. We had water. We had a CO2 fire extinguisher, the little red gun you see everywhere, and we had a lot of sand around. Both to keep this stuff safe, plus sand will help cover that fire and doesn't let any oxygen get to it. Since we need oxygen, fuel, heat, and the spark to create fire, if we take any of those away, so don't let the oxygen get to it, we don't have any more fire. That's what puts it out. Water works a little like that, but it mostly just cools it down. Some things, they can burn really cold. So you got to be careful with those. Simple water wouldn't work. You would need to smother them. Also, you don't want to spray certain things. They could go everywhere. Like if you have a cooking fire and your oil catches, don't throw water on it. You're just going to throw burning oil everywhere.
That's a good
How do
lesson.
you put it out?
How do you put it out, Phil?
Just put a lid on top of your skillet, and it will go out because there's not any oxygen in there anymore. It'll burn it all up. Also, if you've got sand, you can dump sand on it. Do not dump flour on it. Flour will burn, and when it's in a big cloud in the air, it'll make a giant explosion. And it's extraordinarily dangerous. It's destroyed a lot of mills in the past. So, always fire safety. Remember that when we talk about flammable liquids, kerosene, gasoline, alcohol, things like that, it's not the liquid that we're burning, just the fumes off of it. Even though we couldn't see that very well, we could definitely hear it when we did the bottles full of alcohol. We never touched it, but they went off. We got a good fire from that. Next time, we're going to be much safer. We won't need everybody here, although we will probably be back here just because we'd like an assistant for one of the demonstrations. But we'll be doing kitchen science next time, and food. We will be creating our own bacteria colonies and fungus colonies. So if you would like to do that with me, then you will need 2 plastic cups that you can destroy, the little flimsy ones, so you'll need to cut them. You'll need 2 of those for every bacteria colony you want. So if you want 3 colonies, you will need 6 cups. You'll need some plastic tape, just regular Scotch tape or sellotape, whatever you call it. You'll need a piece of bread, or if you don't want a piece of bread, then you can use some gelatin, beef stock, and a little bit of table sugar, which is what I'll be using. In addition to that, you will need either some Q-tips or just some regular cotton balls. So you can collect bacteria from different places to put them in there. All that will be next time. That's all the fire we've got for today. Stay safe.
Awesome. Well, we still have some time left.
Did you?
Yes, so we could
I
do.
was hoping somebody was listening.
You guys want to do a dance party?
Yeah, okay,
Or we can
okay.
definitely do questions.
Oh.
You have
Phil-
host, can you kick over?
Yeah, I think I'm not the host, but does anyone have any questions? And raise your hand if you do,
Or just chat them.
or chat them in the chat box.
Do the Skittle experiment.
Oh, do the Skittle experiment.
What's the Skittle experiment?
Let's.
You put Skittles around the plate and you put hot water on it and it dissolves.
Oh, yeah. I know that one. Okay, that's a good idea for kitchen.
Thanks, Caitlin. Anyone else have any questions
Or other things you'd like to see us
Or-
try in science
or
class.
other things you'd like to see? I think Lauren wants to see more fire.
There are many more fire things. I'm pretty sure that on this table where I've got everything else, and maybe in the car, that we could make gunpowder. But that seems really unsafe. So that's why we didn't do that today.
Got it.
The rocket fuel was probably enough.
Phil, can you name your top 3 MacGyver episodes or creations?
Oh, what? Here's an interesting MacGyver fact, in fact, and it is one of my favorite episodes. We were talking earlier that different metals and salts burn with different colors. By the way, you can take those and just throw any kind of salt into a wood fire, and it'll burn a rainbow of colors. So if you got some Epsom salts sitting around, throw them in the campfire next time. It's a lot of fun. Early, don't dust them in the air. That'll get an explosion as well. The noble gases, neon, argon, xenon, those ones up there, and neon lights, they glow with different colors. When we say it's a neon light, it's probably not neon unless it's one specific color. I believe green for neon, but I don't remember. So they're all different gases depending on the color, and when you run electricity through them, they glow. MacGyver used this to stop a bomb with a mercury switch by taking a neon tube, because your noble gases are inert, they don't react with anything. And he broke it off and shoved it through some wax at the side of the thing. Filled it with an inert gas so he could disarm the bomb without an electrical firing happen and then blowing up the bomb. So that's a really good one. And anyone with Stacy Keach. He's the pilot with the big mustache. I just like that guy. Any other questions or ideas?
Caitlin
Yeah.
has one.
Did the pop explosion? Like melted in the pop.
Yeah.
We can definitely try that. I know that Jonah has seen a giant one, and we're trying to reverse engineer making a huge geyser with that. So we can figure that out. That's definitely what we'll do. I know there's a 3-foot hole involved in that one.
That sounds really cool. Anyone else?
Have any great ideas?
Doesn't look like it. So
Yeah.
thanks everyone for joining Professor Phil. We'll be back at the top of the hour. I will leave the session on if you guys want to do some social time. It's our lunchtime social hour, so we'll keep the Zoom up so you guys can talk to each other for a little bit.
Awesome.